Okay, so this lesson is all about solving systems of equations with three variables. So you'll see these referred to as 3 by 3 systems. That means three variables and three equations. So we are looking at 3 by 3 systems today. All right, so how do you solve a 3 by 3 system? The basic idea is make it a 2 by 2 system, solve for those two variables, and then plug it back in and solve for the third one. So in order to do that, we're first going to separate our three equations into two systems of two equations. We're going to eliminate one of the variables, so we just have two variables left, and then we solve it the same way that we did before. So let's go ahead and look at some examples. Okay, so let's look at this first example. I'm going to call each equation a number. So 1, 2, and 3. And I'm going to start by looking at just 1 and 2. So if I just focus on 1 and 2, I've got 2x plus 4y plus z equals -4. And I've got 2x minus 4y plus 6z equals 13. So I've got those two equations, and I want to use the elimination method to get rid of one of my variables. In this case, it's pretty easy to combine these to get rid of one of my variables. I don't even have to multiply anything by anything. I've got plus 4y and minus 4y. So when I add my equations together, I'm going to have 4x plus 7z equals -4 plus 13 would give us 9. Okay, so now I have an equation. Instead of three variables, I've only got two variables. So once you have done that with one set, you want to do that again. So this time, instead of 1 and 2, you want to pick either 1 and 3 or 2 and 3. It doesn't really matter which ones you pick. Sometimes you can pick one and it makes your life a little bit easier than another one. So if we go with 1 and 3, we've got 2x plus 4y plus z equals -4. And we have equation 3 is 4x minus 2y plus z equals 6. Okay, so now in this first set over here, 1 and 2, we got rid of our y's. So that means we want to get rid of our y's in our second set. So right now we have a 4y and a -2y. If I multiply my second equation by -2, then I'm going to have minus 8x plus, oops, I want to multiply by +2, sorry. So I want those to cancel out, but one of them is already negative, so I can multiply by +2. So I get 8x minus 4y plus 2z equals 12. Okay, so I'm just multiplying everything by 2. And the reason I did that is because I want my y's to cancel out with equation number 1. Okay, so once our y's are opposite, I can add these together. And 2x plus 8x is going to give me 10x. My y's cancel out. I have 3z, and I have -4 plus 12 is 8. Okay, so let's call this equation number 4 and this equation number 5. Once you've eliminated a variable in two different sets, take those new equations. So we're going to take 4 and 5, and we're going to do the same thing. We're going to eliminate something again. 4x plus 7z equals 9. And we have 10x plus 3z equals 8. Okay, so what could I multiply these guys by? I'm going to choose which one you're going to eliminate. So I'm going to choose to eliminate my x's. So I can't multiply 4 by something to get 10. That's a nice pretty number. But what I'm going to do is I'm going to multiply my top equation by 5, because 5 times 4 gives me 20. And my bottom equation by 2, because 2 times 10 gives me 20. but I want to make sure one of those is negative so that I can cancel them out. So I want the top and bottom to have an opposite term. So if I do that, I've got 20x plus 35z equals 45. And then I have negative 20x minus 6z equals negative 16. Now I can add those together. My x's cancel out. So first I cancel out my y's. Now I'm going to cancel out my x's. That's going to leave me with 29z equals 29. 45 minus 16 is going to give us 29. And then I can solve for z by dividing by 29. So I get z equals 1. Okay, so I figured out one piece. I figured out what my z is. I still have to find x and y. So work your way backwards. If you go down to these new equations that you found, and you know that z is 1, you can just plug in z. 3 times 1 equals 8. So now we have 10x plus 3 equals 8. So 10x equals 5, and x equals 1/2. Okay, so we have x equals 1/2, z equals 1. All right, so now we have two variables. We have to solve for the third. Go back to any of your original equations. I'm just going to pick the first one, plug in what you have, and solve for what you're missing. So we know that x is 1/2, so I'm going to plug in 2 times 1/2 plus 4, we still haven't found y, and z we said was 1, equals negative 4. 2 times 1/2 is 1, plus 4y plus 1 equals negative 4. So 2 plus 4y equals negative 4 minus 2. We get 4y equals negative 6. Y equals negative 6 over 4, which is negative 3/2. That is your last piece. So we have x equals, let's see, x equals 1/2, y equals negative 3/2, and z equals 1. So sometimes you'll see this written as a coordinate point. You just do it in order x, y, z. So 1/2, negative 3/2, 1 would be your solution to this system of equations. Okay, and that is the first example. Okay, second example. We've got equation 1, equation 2, equation 3. And we want to be able to cancel something out. So in this case, I'm just going to go ahead and I'm going to choose to eliminate my y's, because you can see I've got plus and minus y there, so that would make my life kind of easier. So let's do 1 and 2 and 1 and 3 as our sets of 2. So 1 and 2, and I'm going to eliminate y. So I have x minus y plus z equals negative 4, and number 2 is 2x minus 3y plus 4z equals negative 15. I said let's eliminate y. You can choose to eliminate whatever you want as long as you eliminate the same thing in both sets. So if I want to eliminate y, I'm going to multiply this top one by a negative 3. And that's because I want my y's to be opposite. So this one will become negative 3x plus 3y minus 3z equals 12. Don't forget to multiply that 3 all the way through. People tend to forget that piece at the end. Okay, so now that I've got this new equation where my y's will cancel out, I can add these together. 2x minus 3x is going to give me minus x. My y's cancel out. I have plus z equals negative 15 plus 12 would give me negative 3. Okay, so now I can do 1 and 3. I got x minus y plus z equals negative 4, and 3 is 5x plus y minus 2z equals 12. And I picked eliminating y because I saw that these guys will cancel out without having to multiply anything. So I can go ahead and add these guys. I end up with 6x, my y's cancel out. Z minus 2z is going to be minus z, and negative 4 plus 12 is going to give me 8. So once I have those, it's a system of 2 equations. So I can combine these. I'm going to call this one 4 and this one 5. So now we take equations 4 and 5. We've got minus x plus z equals negative 3. We have 6x minus z equals 8. And in this case, my z's are already opposite of each other, so it makes it real easy for me. I don't have to multiply anything else together. My z's cancel out. I have 5x equals, and negative 3 plus 8 is going to give me 5, which means x is equal to 1. So I've got one piece, and I want to work my way backwards. So pick either equation 4 and 5 and plug it into them. So I'll just take this first one. If x is 1, I've got negative 1 plus z equals negative 3. I'm going to solve for z, and I get z equals negative 2. Okay, so now I have 2 pieces of my equation. I want to take those 2 pieces, pick any equation from my original, and plug it back in. So I'm going to plug it into here. So if I have x minus y plus z equals negative 4, then I'm going to take x is 1. I don't know what y is yet, but my z is negative 2 equals negative 4. So 1 minus 2 is going to give me minus y, negative 1 minus y equals negative 4. Add 1, minus y equals minus 3. So y equals 3. And that's my third piece. So my solution in XYZ form is x is 1, y is positive 3, and z is negative 2. So 1, 3, negative 2 is my solution set. All right, that's example 2. Let's move on to the next one. Okay, so for this one, I'm going to call this 1, 2, and 3. I noticed here that my z's are opposite of each other, so I'm going to go ahead and cancel out my z's in this one. So I'm going to start with 1 and 2, and I've got x plus 4y minus 3z, and 3x minus y plus 3z. And if I combine those together, my z's cancel out. Oh, I forgot to write what they're equal to. Minus 8 and 12. So my z's are going to cancel out. I'm left with 4x plus 3y equals 4. Okay, so that was combining equations 1 and 2. So let's combine equations 1 and 3 next. Okay, so 1 and 3, I've got x plus 4y minus 3z equals negative 8. And I have x plus y plus 6z equals 1. Okay, so how can I get these to cancel out? Remember, you want to cancel out the same variable that you canceled out before. So since we cancel out z here, we want to make sure we cancel out our z's in our new set. So we've got 6z in the second one and negative 3z in the first one. So I'm going to multiply this first equation by 2. So that gives me 2x plus 8y minus 6z equals negative 16. Okay, so I'm doing this. I'll bring my other one over, x plus y plus 6z equals 1. I'm doing that so my z's will cancel out just like I did before. So if I combine these, now my z's cancel out. I'm left with 3x plus 9y equals negative 15. Okay, so now I've got equations 4 and 5, and I've got two equations and two variables. So this becomes just like we did in the last section. We take that 4x plus 3y equals 4, and 3x plus 9y equals negative 15, and I want these guys to cancel out. So how can I get them to cancel out? Well, if I have a plus 9y here, I can multiply this guy by negative 3. So that's going to give me negative 12x minus 9y equals negative 12. I can keep the same equation on the bottom, 3x plus 9y equals negative 15. And now when I add them together, those y's cancel out. So I've got negative 9x equals negative 27. And so I can divide by negative 9, divide by negative 9. And those can reduce. That would give me negative 27 over negative 9 will give me positive 3. Okay, so I get x equals 3. You can plug that x into either of your previous equations. So I'll just go right here. 3 times 3 plus 9y equals negative 15. So that would be 9 plus 9y equals negative 15, which would be 9y equals negative, let's see, subtract 9, 24, and then divide by 9. So y equals negative 24 over 9. Those are both divisible by 3. You'd get negative 8 over 3. Okay, so we have a y and we have an x. We still need to solve for z. So go back into your original equation. It doesn't matter which equation you pick. So I'll just go for the first one. I have, see, x plus 4y minus 3z equals negative 8. My x is 3. I found y to be negative 8 over 3 minus 3z equals negative 8. So that would be 3 minus 24. Nope, that's 32. 4 times negative 8 is negative 32 over 3. Minus 3z equals negative 8. You can multiply everything by 3 in order to get rid of fractions. So that would give you 9 minus 32 minus 9z equals negative 24. So that's going to give me negative 23 minus 9z equals negative 24. If I add 23 to both sides, I get minus 9z equals negative 1. So z equals 1/9. And that is my third piece. So I have x equals 3, y equals negative 8/3, and z equals 1/9. So you can write that as one solution set. X is 3, y is negative 8/3, and z is 1/9. And that's your answer. Let's go on to the next one. All right, example number 4. Let's go ahead and start with, we've got 1, 2, and 3. I'm going to start with equations 1 and 2. So I've got 2x, erase that, write it a little clearer. Got 2x plus y minus 3z equals 0 for equation 1. I've got minus 2x plus 2y plus z equals negative 7. And in this case, I don't have to multiply by anything because I can see my x's will cancel out. So I'm going to add these together. My x's cancel out. I'm left with 3y minus 2z equals negative 7. So just adding vertically there. Okay, I've got 1 and 2. Now let's do 1 and 3. You could also pick 2 and 3. That would be fine. You'll end up with the same answers. So I'm going to keep doing the same pattern. 2x plus y minus 3z equals 0. And 3x minus 2y minus 3z equals 7. In this case, if I got rid of my x's over here in my first equation, I need to get rid of my x's over here. So if I want to eliminate my x's, I'm going to multiply the top one by 3, the bottom one by 2, but I want one of those to be a negative. So I'm just going to make the second one negative, but you can make either one negative so that they have opposite values. So the top becomes 6x plus 3y minus 9z, and 3 times 0 is 0. And my bottom equation is going to be minus 6x plus 4y, because negative 2 times negative 2 gives me a positive. And then negative 2 times negative 3 is plus 6. And then negative 2 times 7 is minus 14. Okay, so now I can add those together. My 6's cancel out, so I'm going to be left with 7y minus 3z equals negative 14. Okay, so now I have my two new equations, equations numbers 4 and 5. So once I have those two, I want to put those together and see what I can eliminate. So 3y, eraser, minus 2z equals negative 7, and 7y minus 3z equals negative 14. If I want my z's to cancel out, I'm going to well, you can pick either one to cancel out. You can pick your z's to cancel out or your y's to cancel out. I'm just going to pick the z's because they have smaller numbers in front. So I'm going to multiply the top by 3 and the bottom by 2 so that my z's will both be 6's, and then you need to make one of them negative so that they'll have opposite signs. So we have 9y minus 6z equals negative 21. And then on the bottom we'll have minus 14y plus 6z equals, and negative 2 times negative 14 is going to be positive 28. So my z's will cancel out, and 9 minus 14 would be negative 5 equals negative 21 plus 28 would be 7. And then if we solve for y, we get y equals negative 7 over 5. Okay. Y equals negative 7 over 5. Okay, so we've got one piece. Now we have to find what's left. So you can go ahead and pick either equation 4 or 5, one of the ones with 2 pieces, so you can find the missing piece. So I'm going to plug that back into number 4. So So if y is negative 7/5, we got 3 times negative 7 over 5 minus 2z equals negative 7. So that would be negative 21 over 5 minus 2z equals negative 7. I'm going to multiply everything by 5 to get rid of my fractions. So I'll have negative 21 minus 10z equals negative 35. Then add 21. That's going to give me negative 10z equals 14. So z is equal to negative 14 over 10, which is negative 7 over 5. Okay, so we've got y equals, oops, that would be negative 14, and this would be positive. Sorry about that. Watch the signs. Okay, so we get z equals positive 7 over 5, and y equals negative 7 over 5. How do we find what's left? We plug it into any of the original equations and solve for x. So we could plug into that first one. So we're looking for x. Our y is negative 7 over 5. Our z is positive 7 over 5, and it's equal to 0. So that's 2x minus 7 over 5 minus 21 over 5 equals 0. We can multiply everything by 5 to get rid of our denominators. So we have 10x minus 7 minus 21 equals 0, which is 10x minus 28. 10x equals 28. X equals 28 over 10, which if you divide both top and bottom by 2, you get 14 over 7. I'm sorry, 5. 14 over 5. And that is your last piece. So XYZ form, our x is 14 over 5. Our y is negative 7 over 5, and our z is positive 7 over 5. And that is our solution. All right, example 5. We're over halfway through. We can go ahead and pick to cancel, but notice as you're looking at these that this third one is already missing a variable. It's already missing x. So this actually saves us a lot of time, because what we can do is take equations 1 and 2 and get rid of our x's, and then we don't have to combine another 2 equations because we already have a third equation with just 2 variables. So we'll start with 1 and 2 just like we did before. X plus y plus z equals 5. And x minus 2y plus 4z equals negative 1. If we are already missing an x, then what I want to do is cancel out my x's when I combine these. So I'm going to multiply one of these by negative 1. So my x's will have opposite signs. So that means I'm going to have x plus y plus z equals 5 on top, and minus x plus 2y minus 4z equals positive 1. So remember that negative goes all the way through to the other side. Now when I combine these, I've got x's cancel out, 3y minus 3z equals 6. Okay, so now I have an equation in 2 variables, and I already have this one in 2 variables. So I don't have to go the extra effort of eliminating a variable from another step. Okay, so I can combine these guys. So I've got this one, this is my 4th equation, and this 3rd equation. Okay, so I've got 3y plus 4z equals negative 1, and I have 3y minus 3z equals 6 from over here. If I want to cancel something out, well, both of these have 3 y's, so I'm just going to multiply one of them by negative 1 again. Okay, so my new equations, I've got 3y plus 4z equals -1, and then minus 3y plus 3z equals -6. And I can combine those, my y's cancel out. I've got 7z equals -7, so z equals -1. All right, so now that I have that one, I can plug my z into either of my two variable equations. So I'll just go ahead and plug it in here. So I've got 3y minus 3 times z is -1 equals 6. So I'm just plugging my z into that equation. That's 3y plus 3 equals 6. 3y equals 3 by subtracting 3 on both sides. So y equals 1. That's my second piece. Now that I have two pieces, I can go back to my original equations and find the missing one. So x plus y plus z equals 5. I'm looking for x. I know y is 1 and z is -1. And 1 plus -1 is 0, so I get x equals 5. And that is my third piece. So x, y, z, my solution in x, y, z form is 5, y is 1, and z is -1. And that is example 5. Okay, so this next one, again, we're going to start off the same way. We've got 1, 2, and 3. In this case, they all have 3 variables, so we can't take that same shortcut. Let's just start with 1 and 2. So I've got 2x minus 3y minus z equals 0, and I've got minus x plus 2y plus z equals 5. Now, if you notice, in this case, my z's cancel out without me having to multiply anything together. So if my z's cancel out, I'm going to get 2x minus x would be x, and minus 3y plus 2y is going to give me minus y equals 0 plus 5 is 5. So there's one combination. So if I did 1 and 2 before, in this case, I'm going to go ahead and do 2 and 3 because those z's will cancel out and I won't have to multiply anything together. So instead of doing 1 and 2 and 1 and 3, this time I'm going to do 1 and 2 and 2 and 3 because it makes my life a little bit easier. So I've got minus x plus 2y plus z equals 5. And I've got 3x minus 4y minus z equals 1. Okay, and if I combine those, my z's cancel out, so that'll give me 2x minus 2y equals 6. Okay, so I've got my fourth and fifth equation. All right, so once I have that, I want to combine those to eliminate something. So if I've got x minus y equals 5 and 2x minus 2y equals 6, I'm going to multiply this top one by -2 so that my x's will cancel out. So that gives me minus 2x plus 2y equals -10. And then on the bottom, I still have 2x minus 2y equals 6. When I add those together, my x's cancel out and my y's cancel out. So I just have 0 on this side. And I have -10 plus 6 is -4 on the other side. 0 equals -4 is not a true statement. So at this point, you can stop and say no solution. Okay, so that will never be true. There is no solution to this. So that means that somewhere in there we've got a parallel line. Right? And let's go on to example 7. Okay, so this is our last example. You'll notice in this one we already have this one in 2 variables and it's missing the y. So what we want to do is look at our other 2 equations and get rid of the y. So in this case, we call this 1, 2, and 3. we're going to focus on equations 2 and 3, and we want to get rid of our y variable. So we've got 4x minus 2y plus z equals 7, and 2x minus 2y minus 7z equals negative 19. So I'm going to multiply the bottom by negative 1 so that my y's will cancel out. So that means I'll have 4x minus 2y plus z equals 7, and on the bottom I have minus 2x plus 2y plus 7z equals 19. Okay, so now if I combine these, my y's cancel out. I've got 2x plus 8z equals 26. Okay, so 2x plus 8z equals 26. I'm going to combine that with this one over here, my first equation, those in two variables. So now I'm going to look at 1 and 4. We'll call this one number 4. And so I have x plus 4z equals 13, and then 2x plus 8z equals 26. And then when we are solving this, we're trying to eliminate a variable. So I'm going to multiply this top one by negative 2 so my x's cancel out. So I'll get minus 2x minus 8z equals negative 26. And I have 2x plus 8z equals 26. So this time when I combine them together, I'm going to get these cancel out and these cancel out, so I have 0 equals 0. That is always true. So we say in systems of 3 variables, we say there's an infinite number of solutions. And that is the last example. If you guys have any questions on this, feel free to reach out, and good luck.